A conveyor stops mid-shift, a forklift won't start, a pump starts leaking, and suddenly everyone needs answers. Who's going to fix it? When was the last service? Do we have the right part on hand? And where opens the record from the previous repair? Instead, people start calling around, opening old spreadsheets, digging through folders, while the equipment just sits there. That scramble costs real time and money before a wrench even touches the machine. I'm Mirko Peters from M365 FM, and this knowledge nugget explains Dynamics 365 Asset Management in plain English. eTautum's part of Dynamics 365 Supply Chain Management, and it gives companies one place to track equipment, maintenance work, costs, and service history. Later, we will see how a sensor warning can turn an emergency repair into planned work. But before we get there, we need to look at the physical assets a business relies on every single day. Why physical assets become a business problem. Let's must think about the equipment that keeps normal work running. A factory might have production machines, conveyor belts, motors, and pumps. A warehouse depends on forklifts, loading equipment, and sorting systems. A transport company needs trucks that actually leave on time. And an office or facility team looks after heating, cooling, generators, and lifts. Every one of these items does a job, but every item also comes with a set of questions that do now TMT disappear just because the equipment is working today. Where is it right now? Who looks after it? Is it still performing well? When was the last inspection or repair? Those questions sound simple, until the answers live in 5 different places. One technician might know that a machine items a strange noise means trouble because they have worked beside it for years. Another person keeps a spreadsheet with service dates, purchasing files, part orders somewhere else. Finance sees invoices and costs, but not always the full repair story behind them. Then that technician takes a holiday, changes jobs, or simply is not on shift. The knowledge leaves the room. This used to happen all the time with paper service sheets, folders in a workshop cabinet, and spreadsheets passed around by email. A team could still keep equipment running, but finding the full picture took time. People often worked from incomplete information. When equipment breaks, the problem spreads fast. Operations may lose production or slow down deliveries. The maintenance team has to find the fault. Purchasing might need to rush an order for a missing part. Finance later sees an expensive invoice, but cannot always connect that cost back to the specific machine or repair. Nobody plans a breakdown. Emergency work also changes how people behave. A team orders the first part they can find, pays extra for fast delivery, or skips the usual planning because the machine needs to run again. Sometimes that tempts the right call. But when every repair feels like an emergency, costs climb and the same fault keeps coming back. Different people need different parts of the same story. Maintenance workers need repair details and past notes. Operations needs to know whether equipment can run. Purchasing needs to know which parts are required. Finance needs a clear cost trail, and managers need to see where failures and spending keep showing up. Dynamics 365 Asset Management keeps that working record together for physical equipment and the maintenance jobs tied to it. It does now come to replace the person who knows how to repair a motor. It gives that person and everyone around them a shared place to record what happened and find what they need. Before anyone can plan repair work, the system needs a clear picture of each individual asset. The asset record, a digital file for every machine. So here's how to think about asset management. Picture a filing cabinet in the maintenance room where every machine gets its own labeled folder. The difference is this folder lives inside Dynamics 365 Supply Chain Management, and the right people can find it without digging through a cabinet or asking around. Open the folder for a machine and you start with its identity. Record its name, product or model number, serial number, and a plain description of what it does. Throw in technical details and warranty information too, so the team can check whether a repair falls under vendor coverage before ordering parts. That sounds basic, but it stops a real headache. 2 machines on the same floor can look almost identical while their parts, warranty dates, or service needs are completely different. A clear asset record tells the team exactly which machine they're dealing with. The record also needs to answer a practical question: where does this equipment work? Dynamics 365 Asset Management uses something called functional locations for that. Think of a functional location as the place where an asset does its job, not just a pin on a map, but something like a site, a building, a warehouse, a workshop, or a production line. Here's an example. Imagine a company with 3 plants. Inside one plant sits a packing area. Inside that area runs a conveyor line. That conveyor includes several motors, sensors, and rollers. You can describe that whole structure in the system from the larger location all the way down to the equipment that people actually inspect and repair. The plant sits at the top. Below it, the production line. Under the line, the conveyor. Under the conveyor, a motor. And below the motor, you might track a component that needs its own attention. This parent and child structure helps people understand where an asset belongs and what it connects to. So when a motor fails, the technician doesn't just see a serial number, they see that it belongs to conveyor line 2 in the packing area at plant north. That context helps the team estimate what work might stop while the motor is out of service. Equipment also moves. A forklift may shift from one warehouse to another. A pump may leave storage and get installed in a building. After a process change, a machine may move from one production line to a different one. Asset management can track those changes through the functional location. And that matters for costs too. When an asset moves, the system connects its maintenance costs with the financial details of the new location. So if a machine now works in a different plant or department, the cost follows the machine to the place using it. You don't have to guess later which part of the business carried the repair bill. Now, a folder with only the original machine details wouldn't help much after the first year. The useful part is the history beside the asset record. Inspections sit next to repair work. Replaced parts sit next to labor time. Technician notes, fault details, and recorded downtime all become part of the same equipment story. A new technician can check what happened last time. Maybe they find the same motor received 2 repairs in 6 months. Maybe a certain part keeps wearing out. Or an earlier note explains a setting that needs checking before anyone takes the machine apart. The system doesn't remember better than people do, but it gives people a place to leave useful information for the next person. One point needs clearing up. Asset management focuses on physical equipment that needs regular care, repair, inspection, or service over time, or think machines, production equipment, vehicles, building equipment, and similar working assets. It isn't the tool for tracking office laptops, phones, or software licenses. Those items may matter to a company, but a production machine with moving parts, service needs, and downtime risk creates a different kind of record. Asset management focuses on that maintenance story. Once each asset has a clear identity, location, structure, and history, the conversation changes. Instead of waiting for equipment to fail and then asking what happened before, a team can start planning the care that equipment actually needs. Preventive maintenance? Fix it before it fails. There are 2 ways maintenance usually begins. The first is reactive work. Something fails, production stops, and people repair it because they have no other choice. The second is planned maintenance, where a team looks after equipment before a fault turns into a stop, using the manufacturer's guidance along with what the equipment actually needs in daily use. That difference changes the working day. A manufacturer might recommend checking a pump after a set number of running hours, but a pump working in a dusty, hot area may need attention sooner than the same model in a cleaner place. Asset management gives the maintenance team a way to plan around both the manual and the real conditions on site. Planned maintenance isn't about repairing equipment that works perfectly. It's about doing small, known jobs at sensible times, so a small issue doesn't grow into an unexpected failure during the busiest shift of the week. A maintenance plan can cover recurring work like visual inspections, cleaning, lubrication, safety checks, testing belts or filters, and replacing parts that wear out over time. Think about a forklift. It needs regular checks on brakes, tires, fluid levels, lights, and battery condition. None of those checks feel dramatic on their own, but missing them repeatedly can lead to a forklift failing when a warehouse needs it most. The same idea applies to a production line. A technician may clean a sensor every week, check belt tension every month, and replace a part after a known period of use. Asset management helps the team record those routines and surface the next piece of work when it's due. Schedules are one piece of that picture. A job can come due every week, every month, or after a set number of days. But calendar dates aren't always enough because 2 machines of the same type may work very different hours. One machine might run 1 shift each day, another might run around the clock. Technical readings give the team another way to judge when maintenance should happen. Depending on the equipment, that could include running hours, distance traveled, temperature, pressure, or another measurement that tells the team something about its condition. You don't replace a part just because a date appears on a calendar. You replace it when the plan, the equipment use, and the readings show the work is due. Maintenance rounds help with this kind of regular care. A round gives a technician a planned route or set of inspections across several assets. Instead of treating every check as a separate surprise, the worker inspects related equipment during one routine visit and records the results as they go. Imagine a technician starting a morning round in a packing area. They check a row of conveyor motors, listen for unusual sounds, look for loose fittings, and record the readings the company cares about. The work becomes consistent even when different people take the round on different days. Now imagine one of those checks tracks vibration on a motor. For several weeks, the reading sits in its normal range. Then it begins creeping upward. The conveyor still runs, so nobody outside maintenance may notice a problem yet, but the repeated reading tells the technician something has changed. That gives the team time to inspect the motor before it damages itself or stops the line. This is called condition-based maintenance. Rather than acting only on a fixed date, the team watches a technical value. When that reading crosses a limit the company has set, a maintenance need can appear for someone to review. A sensor can feed those readings into the process, but it doesn't repair anything. It can warn that a temperature is too high or vibration has moved beyond an accepted range. A person still needs to check the equipment, decide what the warning means, follow safety rules, and carry out the repair or inspection. That human step matters. A reading might point to a worn bearing, but it could also come from a loose fitting, a sensor problem, or a change in how the equipment runs. The system brings attention to the condition. Trained people decide what action belongs next. So the aim isn't to predict every failure perfectly. It's to give maintenance teams earlier notice, better routines, and fewer repairs that start with a rushed phone call after equipment has already stopped. Planned work still needs a clear job record, someone responsible for it, the right parts, and a way to track the cost. Work orders, the job ticket that holds the repair together. So when does a maintenance need become real work? It becomes a work order. Think of it as the job ticket that follows a repair from the first report all the way to the finished job, giving the team a single record of what went wrong, what needs to be done, who owns the work, and what it eventually costs. Without a work order, a technician might still fix the problem, but the details can vanish into a phone call, a shift handover, or someone's memory, and later nobody can easily answer what work happened, how long it took, or whether the same fault has returned. And without that record, you're left with guesswork. Now, a work order can start in several ways. It might come from a planned maintenance job that's due, from an inspection that finds a fault, from a breakdown when equipment stops, or from a technician who finishes one repair, spots another issue, and creates follow-up work before leaving the site. Different reasons, but the same structure. The work order turns a maintenance need into something the team can schedule, assign, track, and close. So whether it's planned or unplanned, the work order captures the reason and the response. First, the work order describes the job. A short title might read, Inspect Unusual Vibration on Conveyor Motor 4. Below that, the maintenance team can add the tasks needed to complete the work, like isolate the equipment, inspect the motor mount, check bearings, test the repair, and return the machine to service. That level of detail helps when the job changes hands. A checklist can guide the technician through work that must happen in a certain order, which is useful for regular inspections and helps with repairs where a missed step could create safety risks or leave the equipment running poorly. Safety instructions belong with the work too. The worker may need to lock out power before opening a panel, wear protective equipment, or confirm a line has stopped before touching moving parts. The work order gives the team a place to include those instructions where people will see them during the job. Then comes the planning. The maintenance team can assign the workers, estimate how long it should take, and schedule a date and time. That doesn't mean every repair runs exactly to plan, because equipment failures rarely read the calendar, but it gives the team a clear starting point. You can also add the parts and supplies the job needs. For our conveyor motor, that could include a replacement bearing, bolts, grease, or maybe an entire motor. The work order links the repair with the items required, so the technician doesn't arrive ready to work and then discover the part is missing. That means the technician isn't stuck waiting for a part that never arrives. If stock already holds the item, the team can plan around that supply. If stock can't cover it, the need moves into the purchasing process, and someone can order the required part without relying on a rushed message or a handwritten note that gets lost on a desk. The work order still keeps the repair story connected to that purchase. This is where the job ticket starts doing more than describing a fault. It's like a central command post that everyone can look at before they start their part of the job. It helps people prepare before the work begins. The technician knows what to inspect, the planner knows who should take the job, the store team can see which parts are needed, and purchasing can act when a part isn't available. As work moves forward, the order records its status. It begins as created, then someone schedules it. When the technician starts work, the team records that change. After the repair, it moves to completed, and a manager or another responsible person can review it before the record closes. Those steps may sound like admin work, but they answer practical questions. Is anyone dealing with this? Has the job started? Is the machine ready to return to normal use? Did someone check that the work meets the required standard? And those questions are exactly what a maintenance team needs answered during a busy shift. The completed work order also records what the repair used, labor time, parts, and other expenses and the system connects those costs with the asset involved. Over time, that gives the company a clearer picture than a pile of invoices. A manager can see that one motor needed repeated repairs, and the maintenance team can compare the cost of ongoing repairs with the cost of replacing equipment without searching through separate systems and guessing which bill belonged to which fault. The final part is often the most useful for the next technician. When the work ends, the technician can add notes about the fault, the checks completed, the part replaced, and anything worth watching. Maybe the bearing failed because the mount had loosened. Maybe the repair fixed the noise, but the motor should get another inspection in 2 weeks. That note stays with the completed work, so months later, someone facing the same issue doesn't start from zero. They can see what happened before, what worked, and what the earlier technician noticed. That continuity can save a lot of time down the road. A work order explains one maintenance job from start to finish, but its wider role appears when that job connects with the stock records, purchasing activity, and cost records around it. And that's the real value of a work order. It's not just a document, it's a tool that keeps the maintenance operation running smoothly. Connected to supply chain, finance, and fieldwork. Think of a business like an office building. Asset management is the maintenance room. It focuses on keeping equipment working, but it isn't cut off from the rest of the building because the parts store, purchasing office, finance team, and service workers all need pieces of the same information. Asset management isn't isolated OW, it's connected to every other department through the work order. That connection saves people from copying the same details into separate places. That means less chance for errors and a lot less wasted time. Inside Dynamics 365 Supply Chain Management, maintenance work can connect with the stock records for spare parts and supplies. If a repair needs a bearing, a filter, or a replacement motor, the team can check whether that item is already available before anyone starts chasing vendors. Stock tells you what sits on the shelf. When the needed part isn't there, purchasing can work from the same maintenance need, and a purchase order connects to the repair work, giving everyone a clearer view of why the item was ordered and where it will go when it arrives. Production also sits close to this process. If a machine needs planned downtime, operations can see that maintenance work may affect a line or a warehouse process. That doesn't remove the need for people to talk to each other, but it gives those conversations a shared record instead of a chain of guesses. So when maintenance and production share the same system, there's less friction. Finance needs a different view. A maintenance team thinks about the fault and the repair, but finance needs to know where the spending belongs. Asset management can link asset costs to the functional location where the equipment works, so repair spending follows the machine to the right plant, department, or business area. Imagine the same type of machine running at two different sites. Both need repairs, but one site uses it far more heavily. When costs connect to the correct location, managers can see which site carries the spending instead of seeing one large repair total with no useful context. That makes cost conversations less confusing and helps a company spot patterns. If one location keeps spending heavily on the same type of equipment, the team can ask better questions. Does that site run longer shifts? Does it need a different maintenance plan? Or does the equipment itself need replacing? It's these patterns that drive better maintenance decisions over time. Asset management can also connect with Dynamics 365 Field Service. Asset management commonly tracks equipment a company owns and uses inside its own operation, while field service focuses on work performed for customers, often at customer locations. When those areas share related service information, a business can keep a clearer view of equipment, service activity, and the people doing the work. One company might maintain machines in its own factory while also sending technicians to repair equipment it sold to customers. Those are different jobs, but the service history, equipment details, and repair habits can connect where the business needs them to instead of living in unrelated records. Sensors add another source of information. Azure IoT Central can receive readings from connected equipment such as temperature, pressure, or vibration. When a reading moves outside a limit the company has chosen, it can trigger a maintenance response for someone to review. The sensor provides the signal, but the technician still decides what that signal means and whether the equipment needs inspection, repair, or a closer look. The warning can reach the maintenance process while the equipment still runs rather than after a fault stops it. This kind of early warning can prevent a minor issue from becoming a major breakdown. Some jobs also need more than a written checklist. Dynamics 365 guides, used with HoloLens, can give technicians step-by-step guidance while they work on complicated equipment. A worker can follow instructions in front of them, which helps when a task has many steps, or when an experienced technician's method needs to be shared with newer staff. That doesn't turn a beginner into an expert overnight, but it gives the technician practical guidance at the point where the work happens, while the maintenance records keep track of the job around it. Many people expect one business app to handle every job by itself, but it doesn't work that way. Asset management handles the maintenance side, while connected parts of Dynamics 365 handle stock, purchasing, finance, customer service, and other work. The benefit comes from records passing between those areas without people retyping the same details or losing the reason behind them. It's the connections between these systems that make the platform powerful. So let's bring those connected rooms together through one simple maintenance story. Now you have a clear picture of how asset management fits into the larger Dynamics 365 ecosystem. A day in the life, from warning to completed repair. Imagine a warehouse conveyor motor sending unusual vibration readings. That's the warning before failure. Here's the process. You open the asset record, see the motor's location, history, warranty, and scheduled work. Then you create a work order, assign a technician, list inspection steps, and check stock for the bearing. If the bearing isn't available, the system orders it while tracking time and cost. After repair, the technician logs the result and leaves notes. The manager sees cost, repeat faults, downtime, and all maintenance around that motor. The warning didn't fix the motor, it gave people time to plan instead of starting with an emergency scramble. So who it fits and what it does not replace. So who needs asset management? Any company that depends on machines, vehicles, production equipment, or building equipment. That includes manufacturers, warehouses, transport teams, utilities, and service-heavy operations. But here's the thing, it doesn't replace technicians, safety rules, or judgment. It gives those people one shared record like a medical chart for your equipment, and a planned way to keep everything running. Conclusion: keep the equipment story in one place. With asset management, you keep the asset, maintenance job, parts, costs, and service history in one place. Subscribe to M365.fm for more plain English knowledge nuggets and continue with the next building block.